Hello students, today we look into the topic batteries. Batteries are sources of DC energy. In some instances they are used as the only source of power, while in other they are used as a standby source. Batteries are used as the source of energy in automobiles, mines, aircrafts, substations, telephone exchanges, hospitals, portable electronic and electrical equipment. Nowadays, there are different types and sizes of batteries in use. Batteries are made in many sizes and shapes to meet the requirement of wide variety of electrical loads from heavy duty to low duty and also for the intermittent services. We see here the batteries are used in UPS, in hospitals, in automobiles. In automobiles we use different types of batteries. These are the different types of batteries used in automobiles. See here we have batteries used in trains also. The batteries in trains are used when the train is stationary. These are the batteries we use when the train is stationary. A battery consists of number of cells connected either in series or parallel or both according to the requirement and act as the source of power. Now here we see the cells connected in series. We have 4 cells connected in series. Here the cells are connected in parallel. Here we have 4 cells connected in parallel. Like this, we can have any number of cells connected in series, and also we can have any number of cells connected in parallel. We can also have a series parallel combinations. The connection of cells in these various combinations is called a battery. Now we move on to the classification of cells. Cells are basically classified into 2 types. They are primary cells, secondary cells. We have different types of primary cells such as Daniell cell, Leclanché cell and dry cell. Similarly, the secondary cells are again classified into lead acid cell, nickel iron cell and nickel cadmium cells. Primary cell. Primary cell is a cell in which the chemical reaction is not reversible. That is, once it is discharged, it is not possible to recharge them. They are also known as disposable cells or thrown away cells. The disadvantage of this cell is once it is discharged, it is no longer useful. They are used in torchlights, calculators, transistors, etc. Secondary cells. It is a cell in which chemical action is reversible. That is, after discharging, it can be recharged. They are also known as accumulators or rechargeable batteries or storage batteries. Comparison of cells. Primary cells, secondary cells. Primary cells. Once they are discharged, they cannot be reused. Secondary cells. Once they are discharged, they can be reused by charging them again. Primary cells supply less current. Secondary cells supply more current. Primary cells have less life. Secondary cells have more life. Similarly, the primary cells are used for intermittent operations, but secondary cells can be used for continuous operations. The primary cells are lighter, the secondary cells are heavy. The cost of primary cells is less, but the cost of secondary cells is more. The primary cells requires no maintenance. The secondary cells requires continuous maintenance because they have to be reused by charging them. Now we look into the different types of secondary cells. First is lead acid cell. It is the only acidic cell. Next is alkaline cell. Nickel iron cell and nickel cadmium cells come under alkaline cells. Lead acid cell. It is a type of secondary cell. It occupies a prominent place because of its application in the automobile field. It is the only acid battery that uses an acidic electrode. The active materials of lead acid cell are: the positive plate or the anode consists of lead peroxide, which is chocolate brown in color. The cathode or the negative plate is made up of lead, the sponge lead, which is green color. The electrolyte is dilute sulfuric acid, that is H2SO4. In fact, active material is the material which takes an active part in chemical reaction. The chemical reactions during discharge are: the discharging of a cell means conversion of chemical energy into electrical energy and delivering the current to the external circuit. For lead acid cell, the lead peroxide or PbO2 is used as anode and lead, that is Pb or spongy lead, is used as cathode with sulfuric acid, that is H2SO4, as electrolyte. When the cell discharges, then H2SO4 splits up into hydrogen ions and sulfate ions. As the current within the cell is flowing from cathode to anode, H2 ions move to cathode and SO4 ions move to anode, causing the following chemical reactions. Now we look into the chemical reactions occurring during discharging of lead oxide cell. During discharging, the anode, which is, here we see the anode which is made up of lead oxide. Here the cathode is made up of lead. We have H2SO4 as electrolyte. During discharging, the electrolyte H2SO4 splits into H2 and SO4. The SO4 comes and joins at cathode, so that the cathode combines with the SO4 ions and becomes PbSO4, lead sulfate. Now the grey color cathode turns up into white. Similarly, at anode, the hydrogen ions come and join at anode, that is lead peroxide. The lead peroxide reacts with the hydrogen ions and the electrolyte, which is made up of H2SO4, giving rise to lead sulfate and water. The lead sulfide here again is white in color. So during discharging, both the anode and the cathode turn white. Now we look into the charging of a cell. Charging of a cell means conversion of electrical energy into chemical energy. To recharge a cell, the anode is connected to positive of the battery and cathode is connected to negative of the DC source. Now we look into the chemical reactions during charging. During charging, the anode and cathode both have become into lead sulfate, which is white in color. Now during charging, the electrolyte here again splits up into H2 ions and SO4 ions. Again, here the SO4 combines with what? H2 and becomes H2SO4. The H2 ions move to cathode and SO4 ions move to anode. The H2 ions move to cathode and the lead sulphate combines with the H2 ions, again becoming H2SO4 and pure lead. Similarly, at anode, the lead sulphate combines with SO4 ions and water, giving rise to lead sulphate, H2SO4 and lead peroxide. Now we will take up the parts of lead acid battery. A lead acid battery consists of the following parts: plates, separators, electrolyte, container, cell cover, vent plugs, intercell connector and terminals. The plates consist of a lattice type of grid of cast antimony lead alloy which is covered with an active material. The positive plates are usually made by Planté process, whereas the negative plates are generally of Forret type. Separators. These are thin sheets of non-conducting porous material placed between positive and negative plates for preventing contact between them and thus avoiding internal short circuit of the battery. In addition to good porosity, a separator must possess high electrical resistance and good mechanical strength. These are generally made of plastics, perforated PVC, glass, etc. The next part is electrolyte. It is a liquid which fills the cell compartment to immerse the plates completely. The next is the container. The container houses the plates and the electrolyte. It is made of hard rubber or synthetic plastic material to withstand corrosion and mechanical shocks. The container is sealed at the top to prevent the spilling of the electrolyte. The cell cover. Each cell compartment has a cover made of molded hard rubber. The joints between the cover and the container are sealed with an acid resistant material. The next part is vent plugs. Each cell cover has a hole into which is fitted the vent cap. This cap has a vent hole to allow the gases formed inside the cell. Next is intercell connector. It is used to connect the cells in series. It is made of lead. The next is the terminals. Each battery have two terminals. One is positive, the other is negative. The positive terminal has more size compared to the negative terminal. Next we look into the manufacture of plates. Manufacture of plates. Special preparation of plates is required to give large surface area in contact with the electrolyte, which increases the efficiency of the battery. They are generally Planté plates and Forret plates. Planté plates. Planté plates. In this method, two plates are dipped into dilute sulfuric acid and direct current is made to pass through them. Due to electrolysis, hydrogen and oxygen present reacts with the anode material and gets converted into lead peroxide. Hydrogen collects at the cathode material. Now, if the cell is discharged, the lead peroxide coated on the plate becomes cathode and it does not undergo any reaction with the hydrogen, but the lead plate combines with oxygen to form PbO2 layer. This process of charging and discharging is repeated several times and a thin layer of lead peroxide is formed on the plates. The preparation of negative plates by this method is not advisable. This process is slow and expensive, but the plates produced by this are rigid, mechanically strong and have longer life.
During this process, during charging, the anode becomes lead oxide or lead peroxide and the cathode becomes sponge lead. Due to the consumption of water, the specific gravity of H2SO4 or the electrolyte increases. Here there is a rise in voltage. The cell absorbs energy.
For a process of manufacture of plates, in this method, the plates are in the form of cast lead grid. The interspaces of the grid are filled with a paste. The paste for positive plates is red lead, that is Pb3O4 and sulfuric acid, whereas for negative plates it is lead oxide paste, that is PbO paste. The pasted grids are immersed in dilute sulfuric acid and a direct current is passed through them. Thus, both the positive and the negative plates are formed simultaneously. This method is comparatively cheaper and quicker than the plantain method.
Now, we look into the electrical characteristics of lead acid cell. The electrical characteristics of lead acid cell are EMF, electromotive force, terminal voltage, internal resistance, capacity and efficiency. Now we look into each of these in detail. EMF or electromotive force. The EMF of a fully charged cell is about 2.2 volts. It decreases as the cell delivers current. The EMF depends upon the specific gravity, temperature and the length of the time it was last charged. The next is terminal voltage. The terminal voltage is less than the EMF of the cell due to the voltage drop in the internal resistance of the cell. The terminal voltage falls when the discharge continues. The discharge must be stopped when the terminal voltage falls to 1.8 volts. The fall in voltage also depends upon the rate of discharge, that is, the amount of discharge per unit time. Next, internal resistance. Internal resistance is the opposition offered to the current within the cell. The internal resistance depends upon the specific gravity of the electrolyte, that is the specific gravity of H2SO4, spacing between the plates, that is the spacing between cathode and anode, and also the area of the plates. Now, capacity of the battery. Capacity is the quantity of electricity which it can give out during single discharge until its terminal voltage falls to 1.8 volts. It is measured in ampere hours. It is equal to the product of discharge current and discharge time. The capacity of the battery depends upon the temperature, the rate of discharge and the specific gravity of the electrolyte. The capacity of the battery increases with temperature. The higher the rate of discharge, the lesser is the capacity of the battery. Also, the capacity of the battery increases with specific gravity. Now, the fifth one is the efficiency of a cell. The efficiency of the cell can be expressed in two ways. One is ampere hour efficiency and the other is watt hour efficiency. Ampere hour efficiency is equal to ID, discharge current, into TD by IC into TC into 100. Similarly, watt hour efficiency is equal to VD, voltage during discharge, into ID, current during discharge, and T into TD divided by the voltage due to charging, the current during charging into the time during charging into 100. Here we get both the efficiencies in percentages. Also, the watt hour efficiency can be expressed in ampere hour efficiency. Here we see the watt hour efficiency is equal to ampere hour efficiency into VD by VC, where VD is the voltage during discharge and VC is the voltage during charging. Now we look into the indications of fully charged cell. So how can we say the cell is fully charged? This we can see using considering the following things. First one is voltage. The second is specific gravity of electrolyte. The third is gassing, and the fourth is the color of the plates. Now we look into each of them in detail.
The voltage. During charging, the terminal voltage of a cell increases to 2.2 volts. Specific gravity. During charging, the specific gravity of electrolyte increases. When fully charged cell, its specific gravity is 1.28. It can be measured with hygrometer. Color of the plates. When the cell is fully charged, the positive plate gets converted into PbO2, which is dark chocolate brown in color, and the negative plate becomes spongy lead, which is grey in color. The next is gassing. When the cell is fully charged, due to electrolysis, hydrogen evolves at cathode and oxygen evolves at anode. Gassing at both the plates indicate that the cell is fully charged and the charging should be stopped at this point. Sulphation. It is the formation of white hard crystalline sulphate over the plates due to over discharge or other reasons. This is called sulphation.
Now we will see the causes of sulphation. When the battery is kept idle for a longer period, sulphation is caused. Also, sulphation is caused when the impurities are present in acid or plates. Also, the sulphation can be caused due to over discharging, that is, discharging below 1.8 volts. Sulphation is also caused because of fall of level of electrolyte in the battery. In a battery, the level of electrolyte must be maintained, otherwise it leads to sulphation. Now we look into the remedies for sulphation. The sulphation can be removed by charging and discharging the battery at low rate repeatedly. Now we look into the maintenance of lead acid cells. The discharging should not be prolonged beyond minimum voltage. To maintain the lead acid cell up to a certain period, the discharging should not be prolonged beyond minimum voltage, that is beyond 1.8 volts. Also, the discharging should not be prolonged for a longer time. So, the level of electrolyte should be maintained. It must be cleaned periodically. The vent plug must be kept open for the gases to escape. Also, it must be correctly connected with regards to polarity, otherwise it gets discharged. Batteries are used as the source of energy in automobiles, mines, aircrafts, substations, telephone exchanges, hospitals, portable electronic and electrical equipment. A battery is a number of cells connected. The cells can be connected either in series or series parallel combinations. The cells connected in groups are called batteries. Cells are basically classified into two types. They are primary cells, secondary cells. Now we look into lead acid cell. The active materials used in lead acid cell are: the positive plate or the anode consists of lead peroxide, which is chocolate brown in color. The cathode or the negative plate is made up of lead, the sponge lead, which is green color. The electrolyte is dilute sulfuric acid, that is H2SO4. Electrical characteristics of lead acid cell. The electrical characteristics of lead acid cell are EMF, electromotive force, terminal voltage, internal resistance, capacity and efficiency. The indications of fully charged cell. So how can we say the cell is fully charged? This we can see considering the following things. First one is voltage. The second is specific gravity of electrolyte. The third is gassing, and the fourth is the color of the plates. The causes of sulphation. When the battery is kept idle for a longer period, sulphation is caused. Also, sulphation is caused when the impurities are present in acid or plates. Also, the sulphation can be caused due to over discharging, that is, discharging below 1.8 volts. Sulphation is also caused because of fall of level of electrolyte in the battery. In a battery, the level of electrolyte must be maintained, otherwise it leads to sulphation.
In this session, we have seen what are batteries, the different types of batteries, their manufacturing process and their applications. Okay students, till we meet again, goodbye.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500063. Fax 040 322 0546.